Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to find the rate of change from real-world problems. Now, you have already learned that the slope, which is also known as the rate of change of a line, is the ratio of the change in the y values to the change in x values. We can also write this as change in y, change in x, which for short, abbreviated way would be delta y over delta x, equals rise over run, or we can use the slope formula y2 minus y1 over x2 minus x1. So let's look at some real-world examples of how this might be asked to you. So in example 1, it says the altitude of an airplane is changing at a constant rate. The table shows the linear relationship between y, the altitude of the airplane in feet, and x, the time in minutes. Complete the statement that describes the rate of change of the altitude of the airplane with respect to the time. So it says the altitude of the airplane increases or decreases, we'll circle 1, at a rate of blank feet per minute. So because they're asking for the rate of change, they're simply asking us to find the slope of this linear relationship. So when we're giving a table and not a graph, the easiest way to find the slope is by using the slope formula. So when you're using the slope formula, you want to pick any 2 points in the table, and I try to pick the 2 most friendly points. So for this table, definitely 6, 12,000 would be a friendly point. And I think the next friendliest point would be the 1.5, 25,500. So what I do is I write those down side by side. 1.5, 25,500, and 6, 12,000. All right, and then I'll label this x1, y1, x2, y2, and then we'll use our slope formula. So 12,000 minus 25,500 over 6 minus 1.5. Now I'll be using Desmos, but you can use any calculator that you have. So I'm going to push a fraction bar here and say 12,000 minus 25,500. And on the bottom of my fraction, 6 minus 1.5. So we get negative 3,000. So because we have a negative slope, that means our altitude is decreasing at a rate of 3,000 feet per minute. All right, example 2. The graph shows a student's distance from home as a function of time. So in this graph, we have time graphed on the x-axis in minutes, and it's scaled by ones. And on the y-axis, we have the distance from home, and it's also in miles, and it's also scaled by 1 unit. All right. Now, when I'm given a graph, I generally use change in y over change in x, although sometimes I will use the slope formula. But for this problem, I think I'm going to use change in y for change in x to find the rate of change or the slope. So our directions say to complete the statement that describes the rate of change of the distance from home with respect to the time. So just like the problem above, we'll circle increasing or decreasing and then tell the rate. So when I have a graph, your first job is to pick friendly points. Just like we picked friendly points in the table below, above, we'll pick friendly points from the graph. So I would probably use this first one, 0, 6, follow this down. The next friendly point, looks to be about right here. Okay, once I have my 2 friendly points identified, then I connect them with a right triangle. So to get the change in y, I'm going up. Again, I always start with the bottom point. So I'm going up from the bottom point 1, 2, 3 units. So that's positive 3 because I'm going up. And then 1, 2, 3, 4 to the left. Because I'm moving left, I'm going to put a negative there. So let's complete our statement. The student's distance is increasing or decreasing? Well, because my slope was negative, I know it's decreasing at a rate of 3/4 of a mile per minute. All right, example 3. A contractor's total earnings from a job include a fixed amount plus an amount based on the number of hours worked. The values in the table represent the linear relationship between the number of hours worked and the contractor's total earnings in dollars. Complete the statement that describes the rate of earnings with respect to the time. Pause the video and try this problem on your own. All right, welcome back. All right, I picked 2 friendly points, which to me, they were all pretty friendly. So I just used the first two, 5,63.75 and 15,151.25. Now, because I have 2 points, I used my slope formula, and I labeled this x1, y1, and x2, y2. So I said 151.25 minus 63.75 over 15 minus 5. And then I put that in my calculator, 151.25 minus 63.75 over 15 minus 5. Oh, goodness. Should be on the bottom. 15 minus 5. And that gives me positive 8.75. So in this problem, our rate of change is positive. So that means the total earnings are increasing at a rate of $8.75 per hour. All right, example 4. In this example, I'm going to show you an example of a problem you might see on a standardized test where you may not get the exact answer, so you have to make an estimate. It says, in example 4, the graph models the linear relationship between the temperature of the Earth's atmosphere and the altitude above sea level. Which of the following best describes the rate of change of the temperature with respect to the time? So again, when I'm given a graph, I usually use delta y over delta x, change in y over change in x. So to do that, I want to identify 2 friendly points. Now on this graph, to me, there aren't too many friendly points. Let me follow the line here. Maybe this one, although it doesn't look perfect to me, and maybe this one. Okay, neither of those look exactly perfect. That's why I believe on this one we're going to have to make an estimate of which answer choice is closest to our answer. All right. Now, to get your rise over run, let me change colors here. Here's my vertical change, my rise. I want you to please be careful to note that we are not going up 2 units, because the y-axis is scaled by tens, 20, 10, 0, negative 10, negative 20. This is going up by tens. So this is actually going up 20. So my top number is 20. Now my x-axis is going by ones. So it's going 1, 2, 3, negative 3 to the left. So I'm going to put a negative on there. Now let's put that in our calculator and see what we get. So negative, I'm going to change my equals to approximately. Negative 6.7. Now, looking at your answer choices, there's only one answer that's even close to negative 6.7. So I would go with answer A. And notice in the problem, it did say which of the following best describes the rate of change. So even though we didn't get exactly what the answer choices said, we got close. All right. Example 5. The graph shows the volume of a gas sample, shows how the volume of a gas sample changes as the temperature changes and the pressure remains constant. Which of these best represents the rate of change in the volume of the gas sample with respect to the temperature. So again, because I have a graph, I'm not going to use the slope formula. I'm going to use change in y over change in x. So let me zoom in on this and try to find two fairly friendly points here. I don't know, maybe this one. Keep going. I think this one looks kind of friendly. All right, you don't have to use the exact 2 points I used. Just try to get them as close to being friendly points as possible. All right, on the y-axis, let's see. Okay, let's connect this first of all with a right triangle and then talk about how our graph is scaled. So let's look at the y-axis first. We have 20, and then our next number is 25. So this must be going by ones. 20, 21, 22, 23, 24, 25. Yes, going by ones. So up 1, 2, 3, 4, 5. All right, so I think this is going up by 5 units. All right, so let me write that down over here. Change in y, 5. All right, now let's see what the x is scaled by. Our first value is 0, and our second value is 20. So it cannot be going over by ones. All right, is it going over by twos? 2, 4, 6, 8. No, twos is not big enough. How about fives? 0, 5, 10, 15, 20. Yes, we're going by fives. So this would be, oh goodness, what did I just do here? Let me redraw that. So, all right, let's talk about my jumps. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. So I'm going over, my change in x is 60. All right, now let's put that in our calculator. 5 over 60. And then it gave me a decimal. None of my answers are decimal answers. So on Desmos, you can use this little fraction symbol that you see on the left to convert that to a fraction. Ooh, and in this problem, we got the exact answer. So that means we did a good job when picking our friendly points. If you picked other points, you may have had to estimate your answer, but on this one, we got the exact answer. And that concludes today's lesson, Finding Rate of Change from Real-World Problems.